Alright, well, we're getting going on the Martin Lathe electrical panel here, and this is all that's in the interior of the box. You see that big jumble of unidentified wires on the bottom left, and you know, the contactor, and that's about it. No overcurrent protection, nothing. So this is going to be the beginning of a complete redo. Worry not, all of you safety conscious individuals, the power has been disconnected. We're going to mark up a few wires here and keep tearing this panel down. Got the contactor pulled out there. A few more wires to disconnect on this ground bus, and we can get this panel out of here. Well, would you look at that? More wires. I don't know where they go. There's two green wires coming out of the middle of the gearbox. Not sure where they go. Here are some pictures of the panel as I removed it. It's a nice heavy steel panel. Got some inserts for screws. And I don't know about you, but that looks like a scorch mark to me. And yet more scorch marks. Alrighty, here's Martin Lathe electrical panel redo phase 1, and for the most part, I'm going to show you what we got. Worry not, power is disconnected. All those random wires are plugged into the DIN rail here. I have gone through and identified the first 12 or 13. These extra few down here, no clue. So I'll keep working on that. I left the contactor installed in the original location here. Added the J-style fuse, added a 24 volt DC power supply for control voltage. Got a couple of fuse blocks here to fuse the 24 volt supply. This is the PLC that we'll be using in future videos. For reference, it's an Automation Direct Productivity 1000. Added Panduit all the way around. Added some, fuse blocks you see here. I mean, some ground blocks, some larger style. Some, that's like a 4 or 5 millimeter. This is like a 2.5 millimeter. And a octal relay and a fuse here, and we'll explain that in just a second. I also replaced all of the internal ground wires and just in general clean things up. This contactor, it's a very common Allen Bradley 509 size. What size is this? I believe this is a size 2. Anyway, it was using straight 240 as the control voltage out to the switches, and I don't really like 240 volt control voltage. So what I did was I rewired I took the wires that were originally controlling the contactor, wired them to this octal relay here, and then I used the octal relay to switch the high voltage to trigger the contactor in place of the switches directly. That's just, I like to keep the high voltage in the box if at all possible. So there you go. And it works fine. The octal relay the output of the octal relay is also fused on the high voltage side in order to trigger the contactor here. The box of the system currently does not have an emergency disconnect in it. The emergency disconnect that was in the original control panel is bad, so I've had to order a new emergency disconnect or emergency stop switch. So that is on the way, and other than that, that's pretty good. I get a lot of questions whenever I do anything that's electrically oriented on a machine about how to wire up a 2-button or 3-button control circuit for a contactor. So we're going to go over to the whiteboard and sketch out the control circuit that I'm using here, so you understand how this works. So if you have a machine of your own and you want to replace some controls, or if the controls aren't functioning and you want to debug it, I'll explain to you how a traditional momentary switch setup to control the contactor is done. So let's do that now.
Here's the schematic of the machine as it's currently wired. There is no e-stop switch currently. There's a normally open on switch and a normally closed off switch at the top of the page, clearly labeled. Then you have the contactor, the relay that's going to control the contactor, and the motor. This solid red line represents the control voltage when the machine is at rest. This is 24 volts DC. These dashed red lines represent the high voltage in the box as the machine is at rest. When you press the normally open on switch, a couple of things happen all at once. Voltage is applied to your normally closed off switch, and the coil on the octal relay is energized. This does two things. One thing that happens is that control voltage is passed through one set of relay points and travels back around to your normally closed off switch. The other thing that happens is the contactor closes and high voltage is applied to the motor, energizing the motor. Congratulations, your lathe is now running. This is kind of your normal state of being until you press that normally closed off switch, at which time you'll de-energize the coil in the octal relay and everything will go back to its state at rest.
All right, there you go. Phase 1 of the Martin Lathe electrical box redo is complete. I also have here a gear. This is the original Martin gear that lost some teeth here, and I had a replacement. I drew up a replacement and had it just water jet cut out of aluminum, and it'll work, but I gotta be honest, it looks like shit. But that's for a future video right there. But the electrical box is moving along. It's a whole lot safer now that I at least have fuses in there, and check the wiring out. Like I said, there's no e-stop. I've got to replace that. You got to be safe with these things. So we're going to be working on that in future videos. I hope everyone is doing well. And Stan has announced the bash this year.
So, going to be looking forward to that. I believe the hashtag this year is hashtag Meet Your Maker. It's kind of a nice play. I like that. And I'm planning on attending. So, if this is the early announcement, if you are interested in going to the bash, start making plans now. Anyway, be safe in the shop, and I'll be back with you soon.